Hey, so we are continuing week 1 with our adding and subtracting of our whole numbers. Now, yesterday we just saw our addition and really focused on what's this carry? We say carry the 1 or carry the 2. Why are we saying that? And so we saw that as we broke it down. We're going to do the same thing today with our subtraction. And then when we move forward, it'll be more of just, hey, let's focus on the algorithm because that is the faster technique. It is the more efficient technique. But again, it does connect as to why we are doing things. So let's jump right in here with question number 1, where we're doing a subtraction problem. Yeah, subtraction it is. So much like with your addition, we're simply just lining everything up. So we're dealing with our placeholders, our 1s and our 10s, and we can see the 8 and the 3 are both in the 1. So again, just simply lining it up to the far right, that's kind of the way you're thinking about it. And then all we do is we end up subtracting. So 8 minus 3, 5, 4 minus 2, 2, 25 is our answer. Okay, so why does that work? Well, let's take a little trip back in time and let's break it up. 48 is the number 40 and it's the number 8 together. 23 is the number 20 and the number 3 together. So what we're really doing is we're subtracting from the 1's position, which is 8 minus 3, which is our 5. And then we're subtracting the 40 minus the 20, which gives us our 20. So when we combine that 20 and that 5 together, yes, we still get that 25. So again, faster using this algorithm technique that's over here. And now we're just going to look at, see again, why it ends up working, and then especially how it blends together with our good friend of borrowing that we're dealing with. All right, so let's grab someone else that's off to the side here. Here we go. We've got question number 2. Let's call it 43 minus 28. So instead of doing the algorithm technique here first, let's start with the actual breakdown of this borrowing and how it works so we can see the two connected together. So again, 43 is the number 40 and it's the number 3. And 28 is the number 20 combined with the number 8. We are subtracting. And here's the thing though, we can't do 3 minus 8. We don't have enough. So this is why we say we borrow. We take away a 10. So if we take 10 away from 40, we've got 30. And if we take 10 away, well, we're going to give it to the 3. So if we were at 3 and we add that 10 onto it, well, we've got ourselves a 13 that we're dealing with. Because 10 plus 3 is our 13. And now we can subtract. So 13 minus our 8. Well, it gives us our 5. Remember, use your friends with 10. It takes 2 to get to 10. And then I had 8. So, I had 8. We're trying to get to 13. I had to pause there for a second. And so it takes 3 more to get from 10 to 13. So think of it as that gap there, almost that kind of visual, but you're using 10 as that kind of go-to. It takes 2 to get to 10, and then it takes 3 more to get to 13. Well, I traveled 2, I traveled 3, altogether I traveled 5. And then 30 minus 20, there's your 10. So we combine that 10 and that 5 together, yes, we do get an answer of 15. Now, again, let's look at why with the algorithms. Again, it's going to be faster, it's going to be more efficient, but let's see how the two connect together. So go back to the beginning, 43 minus 28. And let's watch the language we're going to use. I can't take 8 away from 3, so we're going to borrow. So we normally say we take 1 away from the 4 and we make it a 3. Well, let's look at this. That's exactly what happened over here, all right? In the 10s position, which we're in, it became a 30 before, and that's what we've got going on here. But we use the phrase we take 1 away. What we're really doing is taking 1/10's position away. So we're really taking 10 away. And this is why then we say we put the 1 in front. Well, think about what we did over here. Because we took 10 away, we're now giving it to the 1's position. 10 plus 3, there's your 13. And now when we kind of look at it, we can see it. I've got the 13 minus the 8, which is the 5. I've got a 3 minus a 2, all right, which is a 1. So I'm also getting a 15. Very similar here. 30 minus 20, the 3 and the 2 that's there. We're just not breaking it down. So again, algorithm faster, more efficient. We just want to kind of make sure that we're using that language, that lingo that goes along with it. So let's see another one here. Question number 3. 324 minus 185. And I'm just going to stack them up right away for you. And we're going to jump right into that algorithm here. Because again, that is the technique we want to make sure we're adjusting over to. So I see 4 minus 5. I can't do that. So we need to borrow. So I need to take away 1 away. Now remember, we're really taking a tens position away. So we're taking 10 away. So really it's 20. We have a 20 that's there, and we're taking 10 away. That's why it's a 1 that's up there, because it's in the 10, 1 and a 0. So we can add that on, and there's your 14. So 14 minus 5 is 9. Now, let's look at this here. I am actually going to do this here. I think this is a worthwhile one to look at. We got 300, we've got 20, and we've got a 4. We've got 100, we've got 80, and we've got a 5. So we can kind of see what happened here. We took 10 away, and we added that 10 on. So 10 plus 4, there's your 14. Now, again, we can see here, we just say put the 1 in front of it. Because again, we're borrowing a 10. And when we add 10 onto something, well, onto a 1s, it just puts a 1 in front. So we still end up getting our 9 that's here. I'm going to come back over here. We're going to kind of go back and forth here. I can't take 8 away from 1. So again, we're going to borrow. So this is what we would say. We take 1 away, becomes a 2, and we put that 1 with that 2. So it looks like we're doing 11 minus 8, which is 3. Let's come on over here. I can't take 80 minus 80 away from 10. So we borrow. But now I'm in the hundreds position. So I'm going to borrow 100. So if I take 100 away from 300, I've got 200. See the 2, see the 2. Yes, in the hundreds position. And then I'm going to add 100 on. Well, if I add 100 onto 10, we get 110. And that's why we just kind of slip that 1 in front of it, because we're doing that addition problem. So if you kind of see what we got here is, I've got the 11, just like I have over here. I've got the 8, like I just have over here. It's just that we're in the tens position. So how far is 80 from 110? Well, it takes 20 to get to 100. It takes 10 more to get to 110. So altogether, it's a 30. And again, the 3 is in that position, in the tens position. There's my 30 that's there. And I can do 200 minus 100, and I get 100 that's there. And if I came over here, I'd say 2 minus 1 is 1. And again, I'm in the hundreds position. Well, look what happens here. Combine all of this together, we do get our 139. Again, a little faster over here on that left-hand side with that algorithm. But honestly, it shows this is that kind of why it's working. So we're going to go through 2 problems here. And this is the portion where we're going to have you go ahead and pause as you go ahead and work through the problems, and then kind of see if you can talk yourself through it with me as I am doing the problem. So question number 4, we're going to use 578 minus 189. All right, so pause that particular video and see if you can solve it here. All right, so we can see we have a borrowing problem right away. I can't take 9 away from the 8. So this is where we say I'm going to take 1 away and it becomes a 6. And then we're going to add that 1 in front. Now remember, it really was a 70. So now it's a 60. And I'm taking 10 away. So when I have 8 and I give it 10, it's an 18 that's there. And now we kind of repeat the process. Can I do 6 minus 8? No. So we're going to borrow. I'm taking 1 away from the 5, so it's 4. Remember, it's really in the hundreds position. So I'm really taking 100 away, and we're going to give it to the 6. So 160 is the same as saying 16 tens. Now again, this is where if you're like, oh my goodness, you're starting to lose me here, it's okay. Focus on that algorithm and that pattern of we're taking one away and we're just giving it to the previous placeholder. So I took one away from the 5, it becomes a 4. I'm giving the 1 to the 6, it becomes a 16, and now we can subtract. 16 minus 8, yeah, that's an 8. And the last thing is the 4 minus the 1, well, that's a 3. We can do that. So we are at 389. Let's give you one more problem to do. Let's try 8,000, all right, 437, and let's subtract it from 5,325. Hit that pause button, give it a shot. Okay, so now when we subtract, this is nice. We're like excited to see this. 7 minus 5. Yay, we can do 7 minus 5 and get 2. Next one over, 3 minus 2. Hey, we can do that. 3 minus 2 is 1. Yes, no borrowing right now. 4 minus 3, we can do that. That's a 1 as well. And then 8 minus 5, hey, so there's the benefit of that algorithm. If I didn't do it this way, and I realized I broke it on up to that 8,000, that 400, that 30, and that 7, it's just a lot more writing to go along with it, and it's going to take a longer time. So some students, when they realize they have to borrow, they'll go back and kind of break it down because it makes more sense. But again, we want to get you into that algorithm to be using it. So, all right, there you go. We'll see you later.